Second example, a train of weight of 100,000 kilonewtons. Now, the only reason I have the question like this is just to show you what it means when we say an incline of 1 in 50. An incline of 1 in 50 means that the sine of A is equal to 1 over 50. In triangular form, it's not that steep, 1 and 50. So just be careful with this one. Now, I don't think we need cos A in this question. We're just going to use sine A because we're going to find the speed of the train. So we have the train's weight, 100 kilonewtons, so put in 3 zeros there. We have our incline, so we have sine A is 1 over 50. Just jot that down again. And we have resistance to motion, 20 kilonewtons, so 20,000, and max power output. Power is equal to TV. Just write that down if it jumps out at you from the previous video. The tractive effort times the speed. So where can we start with this? Okay, let's always start with a diagram. Here's my train. It's going up a hill where the angle is, the sine of it is 1 over 50. We have our normal reaction. We have resistance to motion. Now there's no acceleration here. It's going at constant speed, so the forces have to match. Let me bring my weight down this way. We're told 100,000. This is W. 100,000 newtons. So we have a force going down this way, and we have a force going in this direction, and the force going in this direction is going to be 100,000 sine A. So we have 100,000 over 50. Use a calculator or don't. 100, knock off your zeros and divide 10 by 5 to get 2. There are 3 zeros left. 2,000 newtons. So the force is going this way. We have the resistance of 20,000, and we have this 2,000 newtons. So this tractive effort, for it to be a constant acceleration, must be equal to those two things. So that's 22,000 newtons. Otherwise there would be acceleration. So we're looking for the maximum uniform speed. Back to this guy here, the maximum uniform speed of the train. We use our power is equal to the tractive effort. It's pulling it at a constant speed. So 440 is equal to 22,000 times the speed. And if we knock off 3 zeros and divide 440, or divide 44 by 22, we're going to just be left with 20 is equal to the speed, and that will be 20 meters per second. So getting on to exercise 6A. A sleigh is pulled by a horizontal force of magnitude 80 newtons. The sleigh moves 30 meters across horizontal ground. Find the work done. Write down your formula. Work is equal to the force by the distance. Jump back up and find each component. Force, horizontal force, magnitude 80. By the distance, 30. 8 threes are 24 with 2 zeros. And that would be in joules. Took 10 seconds. Find the power. Power is equal to this work done. We did 2400, so power to work divided by the time taken 10. So the power here is, just knock off a 0, 240, and power is in wattage. On to number 2. A woman pushes a car by exerting a horizontal force, 200 newtons, and the distance is 12. Again, very similar. Find the work. Work is equal to this force by the distance covered, which is equal to 200 by 12. Not 120, 12. 12 twos are 24 with 2 zeros. 2400 joules. That does spell joules. There might be an L in there somewhere. And what are we looking for next? Again, the power. Same question again. The power is equal to this work done divided by the time taken to do it, which is the 2400 divided by 8. So that's going to give 300. And that again is wattage in watts. And we should finish this video. Maybe one more question. We'll do number 3 as well. So a sled is pulled across horizontal ground by a pulling force of 130. And the force makes an angle. So let's just do a quick little diagram here. My sled, my angle, and my horizontal force in this direction vertical force, we have a force of 130 newtons, and we have A, tan A is 5/12. Quick sketch always helps. 5, your opposite over your adjacent, you know this is 13. So sine A is opposite 5/13, and cos A, the one we want, cos A is equal to 12/13. So the relationship between 13 and 130 divided, we get 10, so this is going to be equal to 120 newtons, this force here. And this force here going in this direction will be the 5/10, 50 newtons. So if it moves a distance of 50, find the work done. So the work is equal to that horizontal pulling force, 120, by distance of 50. 5 12s are 60 with 2 zeros, so 6,000 joules here. And it took 1 minute. Okay, well, just divide by 60. 6,000 divided by 60. 100 watts for whoever is pulling this sleigh. Maybe a dog, maybe a person, who knows. But move on to the next video and try some slightly trickier questions as we move forward in the chapter.